Hey, what's up, students? Let's go over the carbon-covered catapult. So what's going on here is that we have a large number of dead skin cells that are falling off people. According to Google, there's 40,000 dead skin cells that fall every minute, at most, per person. So I'm going to give you all of the skin cells that have fallen in the high school gym over 2 hours and 20 minutes, and we got to work backwards to find the number of people who are in the gym on average. So it's kind of gross, but here we go. So this total dead skin cells, it fell by finding the number of people times the number of cells times the number of minutes. So we're trying to find the number of people. Well, we know the number of cells. The number of cells was 40,000, okay, on average, okay, at most and on average, times the number of minutes. So how do we get the number of minutes? Well, we would have to take 2 times 60 because there's 60 minutes in 1 hour, and then we'd have to add the extra 20. Okay, so when we have 40,000 times this number, we get this number of people times, I have it calculated here, it's 5,600,000. I think that's 5.6 million. Okay, so the number of people times 5.6 million dead skin cells equals this number. So we could actually write that out as a whole number. To be honest, I think it would be easier just to write this out as a whole number. So that would be 6, 938, 1, 2, 3. So there's 3, 6, and then there's the 9th one. Okay, so that's how many dead skin cells were in the gym. Gross. Okay, so we would divide both sides by 5. Actually, you know what I'm going to do? I'm going to cancel all these zeros. Check this out. Here we go. 1, 2, 3. 1, 2, 3. 1, 2. 1, 2. There we go. That's going to make life a little bit easier for us. So let's divide both sides by 56. We divide this by 56. Let's see what we get here. I don't have this pre-calculated, so I'm so sorry. Here we go. 69380 divided by 56 is, I get 1238.9. So to the nearest person, I think there were 1,239 people in that gym. If you wanted to check your work, if you want to throw a 1239 right there and multiply those numbers, you would probably get a scientific notation number about this big. All right, cool. That's how you do that one. I wouldn't even mess with the scientific notation. I would just write them all out as regular large numbers and then just cancel out the zeros so you make life easier for yourself. Sometimes you got to work smarter, not harder. Here we go. Part 2 is the reverse. So we have 765 students and 62 staff. How many dead skin cells would accumulate if everyone stayed in the building for an average of 8 hours? Gross, okay? So let's get the total number of people. So if we add 765 and 62, we're kind of following this formula right up here, so we're going to use it twice. There are 827 people, and they would each, at most, shed 40,000 dead skin cells, and then 8 hours, we would take times 60 to get the minutes. So there's your people, there's your cells, and then together this would be the minutes. So let's multiply that, and we're going to write it in scientific notation. So I don't have this calculation ready. Actually, take it back, I do. When I put it into my calculator, it is, oh, actually I don't. I'm so sorry. I thought I did. This is the worst video I've ever made today. Times 8 times 60. What do we got here? We get, oh, the calculator tells me exactly. It's already in scientific notation. My calculator says 1.587 and noise times 10 to the 10. Okay, cool. I went 3 decimal places, so you would say 1.59, because the 7 would round you up to a 9, and then you would say times 10 to the 10th place. All right, cool. That's how you do the carbon-covered catapult. People times cells times minutes gives you the total dead skin cells. Gross. Solve it by anything, any way you can. Also, don't forget to use the scientific notation resources that I have built for you. All right, see you in class.